In this lesson, we're going to talk about box and whisker plots, and how we can use a set of data to identify the medians, which will then help us identify quartiles, and how those can be used to generate our box and whisker plot. Let's get started. To begin with, we have some terms, and our first term is the range. The range is the difference between the maximum and the minimum value for data. If we look at our range, since it's already in order from least to greatest, we can see our smallest value is 1, and our biggest value is 10, and when we subtract the 2, we get 9. So the range of our data set is 9, and that just kind of indicates how spread out the data is. The bigger the range, the more spread out the data is. The smaller the range, the closer it is. In addition to range, we also have the term quartile. There are 3 quartiles, Q1, Q2, and Q3. To begin with, we normally find Q2, which is the median of the data set. And the median is going to divide it into 2 separate parts. We have the lower quartile and we have the upper quartile. Q1 is a quartile of the lower half, and we find it by identifying the median of the lower half of the data set. Q3 is the median of the upper half, and again we find it by finding the median of the upper half of our data set. So to recap, we're going to find the median of the whole data set, which is Q2, and we have 2 parts, the lower and the upper part. Q1 is the median of the lower part, while Q3 is the median of the upper part. Let's take a look at this data set to verify we understand quartiles. So I've identified Q1, Q2, and Q3. I'm going to make sure they are in fact where they're supposed to be. To begin with, we have 15 terms. So if we look at our formula from class, to find the median, it's n plus 1 over 2, which in this case is 15 plus 1 over 2, which is 8. So Q2, or our median for the entire data set, should be the 8th term. And if we look at our things, we have the first 8 terms here, or from the other side, again, we have another 8 terms. So 6 is, in fact, the median. Once we know that 6 is our median, we have 2 different portions. We have the lower portion, and we have the upper portion. Now notice that when I made these portions, we can see that the median is not part of the upper or the lower portion. If you look at the data set now, we can see that Q2, again, is not part of the upper-lower portion, since there were 15 terms. If we take out Q2, there's 14 terms, which means we're going to have a total of 7 terms below and 7 terms above our median. If we try to find the median of the lower portion, again, using our formula, instead of 15 plus 1, now we have 7 plus 1 over 2, which is 8 over 2, or 4. And we can look at our terms and verify that 2 is the 4th term from the left, and the 4th term for the right. It's also going to be the 4th term to find our Q3, so again 9 is the 4th term for the left, and it's also the 4th term for the right. So we verified that these terms are in fact in the correct spot. And just to recap, Q2 again is the median of the entire data set. I knew there were 15 terms, so I found the median by doing 15 plus 1 over 2 and identified that the 8th number is in fact the quartile, or Q2. When I'm looking for the upper and the lower quartiles, I do not factor in Q2, so I have 7 terms below and 7 terms above, which means, again using our formula, 7 plus 1 over 2 tells me the 4th term will be the quartile for the lower and the upper portion, which means that the 2 and the 9 are in fact the quartiles. If you look at our data set, we have some percentages that apply to our information. So knowing that Q1 is the quartile of the lower portion, we can kind of see that we have 4 quarters. So we have the first quarter, we have the second quarter, the third quarter, and the fourth quarter. So it kind of makes sense that if you look at Q1, there are 75% of the data above it because there's 3 quarters above it, and there's 25% of the data below it because, again, there's 1 quarter below it. And these percentages are going to be true no matter how many data terms we have. There's always going to be roughly 75% above and 25% below Q1. If you look at Q2 and I draw a line in between 6, we can see that we have half below and half above. So it does make sense. If you look at our percentages, we see 50% of the data is above Q2 and 50% of the data is below Q2. Following along with Q3, again, we know that we have our quarters. There are 4 of them. We have, again, quarter 1, 2, 3, and 4. So looking at Q3, there are 3 quarters below that, 1 quarter above it. So in this case, 25% of the data is higher than Q3 and 75% of the data is lower than Q3. Once we're able to identify our quartiles, we can then find the inner quartile range. This is similar to the range for the data set, but this is now the range for the middle 50%. So we have a few standard terms that apply. You can see the interquartile range again is the middle 50%. We find it by doing Q3 minus Q1, and once again we see that there's 50% of the data in between Q3 and Q1. So it's a very simple calculation as long as we can accurately identify Q3 and Q1. Alright, now the important part. Once we have our quartiles, we also want to identify two additional terms. We'd like to identify the maximum value and the minimum value. And these sets create what I call the Fab 5. These 5 numbers are going to be used to create our box and whisker plot. The middle 3 numbers create our box. And we have a line going through for our Q2. The minimums and the maximums create our whiskers. So if you look at the box whisker plot that I have here, again we can see that we have our quartiles. So we have number 2, we have the number 6, and the number 9. And that is creating our box. We always draw a line through to indicate where our median is for the data set. We also see that we have a point at 1 and another point at 10 for our whiskers, and I just draw the whiskers going from Q3 to the Q3 to the maximum, and also Q1 to the minimum. Okay, here's another data set. Why don't you go ahead and take a moment to verify that the quartiles are in fact correct. So hit pause now and try this for yourself. Alright, so hopefully it's the time to try this. There are, in fact, 11 terms. So, using our formula, 11 plus 1 over 2 turns out to be 6. So I am looking for the 6th term. Doesn't matter if we start from the left to the right. So if I start from the left, then I count to 6 and I get 18. If I count from the right, again I count 6 terms and again get to 18. So that is, in fact, our quartile, or our Q2. Once I know what Q2 is, I have the lower part and I have the upper part. There are 5 terms from the lower part, so if I want to find Q1, then I have 5 plus 1 over 2, which is 3. Again, verifying that I have the 3rd term from the left or from the right. I see 13 as the 3rd term both times, and doing the same process for Q3, again I have 23 being the 3rd term from either side. So now I have Q1, Q2, and Q3. To go ahead and use this information to create my my box and whisker plot, I also want to identify the minimum value, which in this case is 12, and the maximum, which is 27. On a side note, just want to emphasize once again that we can do this because the data is in the ascending order from least to greatest. Alright, so here's our box and whisker plot for the data set. We want to verify that everything is done correctly. So once again, we see that the box is going to come from our quartiles. So I have my quartiles here. Q1 is at 13. And then we have Q2, which is at 18, and then Q3, which is at 23. Again, that does create our box. We always draw a line through quartile 2. And then my whiskers are going to go out to the outside for my maximum and my minimum, and again, that is what happens. So we verify that our box and whisker plot has been drawn correctly. It doesn't happen very often, but there are times where we have numbers that are extraordinarily low or high, and those are called outliers. We have a very simple calculation to go ahead and find our outliers. So if I want to find my maximum value, then I would find Q3 plus 1.5 times IQR. And remember, IQR is the interquartile range, which is Q3 minus Q1. So once I've done this calculation, once I've done Q3 plus 1.5 times IQR, that tells me the biggest number I can have in my data set. Which means that if there's a number bigger than that, it doesn't really follow the pattern, and we call it an outlier. We have a similar process to find the smallest number we can consider, so Q1 minus 1.5 times IQR, again will tell us the smallest number we can consider, which means if there's a number that is smaller than that within our data set, it is in fact an outlier. To identify an outlier, any point that is an outlier is going to be exactly that, a point on our box and whisker plot. And the next number, either the next smallest or next biggest, will become the max or min. So let's look at what this looks like by looking at a scatter plot. Okay, here we have an example where we have some numbers that were too big or too small. Looking on the left side, we have a number that was definitely too small. It's so far away from the rest of the data. And then again, we have something that is really big. Again, so much bigger than our other set. So they are outliers. Again, to find this, I would have calculated 1.5 times the IQR and then either added that to Q3 or subtracted that from Q1, the formula from the last slide. And these numbers would have been bigger than either the maximum or the minimum that we can consider. So again, if this does happen, you are going to indicate it's not right by putting it as a dot, and then we can see that the next biggest number in our data set becomes the maximum, or the next smallest number will become the minimum. Alright, hopefully this is enough for you to go ahead and get started on your box and whisker plot. Good luck!